Take note, key concept, biconditional statements. A biconditional combines P implies Q and Q implies P as P if and only if Q using this double-ended arrow. An example, a point is a midpoint if and only if it divides a segment into two congruent segments. In symbols, we state this as P if and only if Q. So note, P implies Q and Q implies P come together to form P if and only if Q. How to read it? P if and only if Q. You can write a biconditional as two conditionals that are converses. Problem 2. Identifying the conditionals in a biconditional. What are the two conditional statements that form this biconditional? A ray is an angle bisector if and only if it divides an angle into two congruent angles. We'll let P and Q represent the following. P, a ray is an angle bisector, and Q, a ray divides an angle into two congruent angles. Our first statement, conditional statement, P implies Q, can be written, if a ray is an angle bisector, then it divides an angle into two congruent angles. And the second conditional statement, the converse of the initial one, Q implies P, can be written, if a ray divides an angle into two congruent angles, then it is an angle bisector. Your turn. What are the two conditionals that form this biconditional? Two numbers are reciprocals if and only if their product is 1.